In section number 9, you will learn about NumPy, another topic that is a performance optimization and best practices. That is very important to know how you can write a efficient and with a good optimization techniques and following the best practices. So in this section number 9, you will find an article and assignment. Article will contain basics techniques of optimization and different best practices you have to follow. So on the other hand, you will find an assignment. You have to complete that assignment. So you can use other resources, you can read books, you can watch video lectures, you can message me requesting me to provide some resources. I will provide different resources, helping materials. You can follow that study materials to complete your assignment. Also, these are the coding exercises. I shared its solution. All the coding exercises I shared their solution with their algorithm. For example, number 1 coding exercise is that vectorization for performance improvement, memory layout optimization, C versus Fortran order, performance, that is actually explore how changing the memory layout affects performance, using NumPy's built-in function versus Python loops, in-place operations for reducing memory usage, profiling and optimizing NumPy code, understanding and utilizing steroids for performance. So these are the coding exercises that are very important and conceptually these are the coding exercises. I will share their solution with algorithm. So these are the different points that you will learn at the end of this section number 9. For example, use vectorization to significantly improve performance, optimize memory layout and understand the impact of different layouts. Choose between NumPy's built-in function and Python loops for efficiency. Implement in-place operations to reduce memory consumption. Profile and optimize your NumPy code for better performance. Utilize steroids to enhance performance in array operations. So these are different points you will get at the end of this section number 9. Don't worry, I will share all these PPT slides with you guys. You can download freely and read each and every lines offline. Hello guys, in this section number 9 we will discuss about more different 6 coding exercises related to NumPy. First problem statement is that to optimize a computing using vectorization instead of Python loops to improve performance with NumPy arrays, I will use vectorization instead of Python loops. Skills required and instruction you need to read. Algorithm I will follow. For example, in the second problem, in the second step, create a large array, perform an element-wise operation using loop, perform the same operation using vectorization. I will not use here a loop. So you can see that importing NumPy array and also time module. So you can see that very large number, it will create an array targeting this size, and also you can start loop time and result underscore loop variable in which you can say that I used the list comprehension ending time. So here I used a vectorization method. So result you will get at the end. You need to copy and paste in your desired ID to check its output. So second problem statement is that to optimize memory access pattern by understanding and utilizing C row major order and Fortran column major order. So these are different order you can follow to access array elements. Skills required and instructions. Algorithm you need to follow. For example, create a 2-dimensional array in C order in Fortran order and then mirror the time to access elements in both arrays. Compare the access times. So these are the actually coding problem solution for that problem statement. You can analyze its output. Just copy and paste in your IDE to check its output. Third problem statement is that evaluate the performance difference between using NumPy's built-in function and traditional Python loops for any operations. We will make a difference between NumPy's built-in function and traditional Python loops. So skill required and instruction you need to understand. Algorithm I will follow. First of all, importing NumPy array, large array you need to create, perform a sum operation using loop, perform the same operation using NumPy's built-in function, compare the execution times. So here you can see that all the steps are implemented using NumPy programming. Perform a sum operation using loop and using built-in function. You can see that sum is a built-in function. This sum is a Python function. So here is comparing execution times. For problem statement is that perform in place operation on NumPy arrays to reduce memory usage during computations. Skills required and instructions. Algorithm: first of all, import NumPy, create a large array, perform an in place operation on the array, print the modified array. So this is a solution. You need to copy and paste in your Visual Studio Code, IDE, or any other to check its output. First of all, you can see that on the third step, this is the in place operation. Fifth problem statement is that profile and optimize a NumPy based code snippet to identify performance bottlenecks and improve efficiency. So this is actually fifth problem statement. Skills required and instruction you need to understand, read carefully. Algorithm I will follow. So third step, you can see that profile a slow operation using %time it, optimize the operations. And then fifth step, reprofile to verify improvements. So this is a problem solution. Last problem statement is that manipulate and utilize steroids in NumPy arrays to optimize performance for specific data access patterns. How you can manipulate and utilize steroids. Skills required instructions. Algorithm you need to follow. First of all, importing NumPy array, create two-dimensional array, use steroids to create a view of the array, and then modify the view and observe changes in the original array. This is actually a solution. You can analyze its output when you take this source code in Visual Studio Code. If you face any problem, you can message me directly.